Hey, it's me, Mr. Truman. I'm back for part 2 of this video. In the last video, we did parallel lines, and we got kind of cut off at the end there because of the old afternoon announcements, which apparently is like 27 minutes long. So anyways, I decided to split this up, made it a little bit easier. So we have a 2-part video. The first part being parallel lines, and now we're in for part 2, which is perpendicular lines. So I'm going to go over a few examples with you about perpendicular lines. My first example is here is going to be from a diagram. I have a a set of lines drawn here, and these lines are perpendicular. And what I want to go over with you is how do they become perpendicular? What makes them perpendicular? And well, there's 2 things that are happening here. One is they are perpendicular because they intersect at 90 degrees. And the reason that happens is due to their slope. And so the first thing I'm going to do is show you that when we have perpendicular lines, I want to make it really clear that we know that that means that these make 90 degrees. Now, why that's going to happen is coming down to our slope. So in the last video, I showed you how we want to pick points on the line, and then we want to count out our slope. So when we go and pick our lines, we're looking for things horizontally, vertically, and then the line that we're talking about, the blue lines, where they intersect. So I'm going to call this one line A, and this one line B. And if I look at the diagram, I'm looking for a place where they cross, horizontally, vertically, and with the blue line. And I kind of like this one right here. You can see everything's lined up there. I also notice that right here on the arrowhead there's another good spot. And if I follow it on down, there's probably another one here, but that's good enough for now. So when I figure out my slope, if I notice from here to here, I have a slope of -4, and it's because I'm going down, and 1. All right, well, if I count that again, just to make sure, down 1, 2, 3, 4 over 1. Yep, my slope is definitely -1/4. Or I'm sorry, -4 over 1. Now, if I look at my other line, my B line, I want to count that slope. And on that one, the slope is, let's see, what are we going to do? We got a point. How about here? This looks good. Maybe here and there. Well, when I do that, let's see, I got to rise 1 and run 4. Rise 1, run 4. Okay, so it's 1/4. Well, that's kind of an odd connection here. Notice something about these 2 slopes. One is -4 over 1, and one is 1/4. Well, we have an explanation for that. That's called opposites and reciprocals, and that's kind of the definition of being perpendicular. So we say the 2 lines are perpendicular if their slopes are opposites and reciprocals. And you notice how the A line went down the page. It has a negative slope of rise 4, run 1. And then the other one goes up the page, and it has a slope of rise 1, run 4. Well, they're opposite reciprocals. And so perpendicular, we just want to kind of keep that in mind. Perpendicular is opposite and reciprocal. I'm just abbreviating here, slopes. All right, so when we look at a diagram, if we take, and by reciprocal, I mean when you flip the fraction, that's a reciprocal. So like -4 over 1 and 1 over 4, those are reciprocals. So I flip the fraction upside down. That makes these lines perpendicular. And when you have perpendicular lines, because of the way those 2 slopes are exact opposites, they always form a right angle. And so we always make sure that we put the right angle symbol when we have perpendicular. All right, let's look at another one. Except in this one, I'm going to go and I'm going to use points to figure out my slope, and then I'm going to verify it by counting. So remember our formula we talked about in the first video was y2 minus y1, x2 minus x1, and basically we're just counting the slope, which is the change in y values and the change in x values. So I'm going to call this one, let's call this x1, y1, x2, y2. All right, so let's calculate the slope. And I'm going to give the blue line, I'm going to give it a name, even though it's got some points on it. I'm going to call this one line L, and I'm going to call this one line N. Okay, so for line L, let's find our slope. So the rule is it's y2, which in our case is -1, minus y1 divided by x2, 5, minus -1. All right, well, let's simplify that. -1 minus 2 gives me -3. And 5 minus -1 actually gives me 6, because when you minus a negative, it turns into positive. So that's 5 plus 1, 6, which that can be reduced. 3/6 is the same thing as saying -1/2. All right, so let me change the pen color, and let's do that again, but this time let's do the red line. And as usual, I like to mix it up so that you don't think it's really imperative that I have one be x1 and the other one. So this time, you know what, I'm going to switch it up. I'm going to put x1 down here, and I'm going to put y1 down here. We'll call this x2 and y2. It really don't matter though, it really, really don't matter. You just need to be subtracting. So let's do our slope. All right, so now I got 2 minus -4. And then I've got 4 minus 1. I don't know why this keeps popping up. It's driving me crazy, but whatever. All right, so 2 minus -4 would be 6. 4 minus 1 is 3. And if I reduce that down, that's 2/1. And once again, I'm looking at these two, and I've got opposite reciprocals. I've got opposite signs. You can see this line here, the blue line goes down a page, whereas the red line goes up the page. And then when they intersect, I notice because I got -1/2 and 2/1, that these two are making a 90-degree angle right there. And that's called perpendicular lines. That's from a graphing perspective. Now, let's look at that from a equation of a line. So say I give you, I say, are the lines parallel, perpendicular, or neither? Well, parallel we covered in the last one was having the same slope, whereas perpendicular is going to mean that they need to have the opposite and reciprocal. So if you need to, you might want to make a little note somewhere, perpendicular, opposite, reciprocal. Just in case we can't remember that, let's just make sure we got both of those going on, okay? Opposite and reciprocal. All right, well, when I look at the one on the left side, that's in standard form. That does not do me much good. Whereas the one over here is in slope-intercept form. So when I have it in slope-intercept form, I know right away, I know that my slope is 4/5. But over there, I'm gonna have to do some work. So what I wanna do is, first off, I'll erase my little, I said write this down. Of course, I write it right where I'm about to use. So I'm gonna rewrite it over here. Let's just remember this. Perpendicular is opposite and reciprocal. Abbreviated because I'm kind of lazy and I don't want to write it all out, but it's opposite and reciprocal, and I just don't have that much space. So let's go back over here and let's take a look. I need to make this say y equals so that I can make a good, solid decision about the slope, because right now I don't really know the slope. Okay, some people will say, oh, the slope's 10. Well, it's not, because you haven't made a slope-intercept. So let's get that right. So the first thing, I need to get it y equals, so I'm going to minus 10x. I'm going to bring down, I got 8y equals -10x plus 16. And I know it's plus 16 because I don't see any negative out front, so it just must be a positive 16. And now I got to divide everybody by 8. I have no idea what's going on with this whiteboard, but it's going so slow. So y equals, all right, well, I got -10x. I can do better than that. I can reduce that. What's 10/8? I know 10 don't divide by 8, but I could at least divide both numbers by 2 and get that down to -5 halves x plus 2. And remember, only thing I really need here is that slope. And I get -5 halves. So now, oh, what am I saying? It's not 5 halves. Look at that. I'm messing this up so bad. That's 5/4. What am I doing? It's definitely after school time. You can tell I'm making some serious mistakes here. But that's all right. Watching me fall on my face once in a while is always good. So 5/4. Well, look at those slopes. -5/4 and +4/5. Those are opposite signs, meaning one of them, the blue line here, this one here, was going down the page, whereas the other one was going up the page. And those two things are perpendicular. So we want to say perpendicular. That's part of my problem right there. That's why I'm a little distracted. All right, we had one more example that I had in our homework that a lot of people had a hard time with, and they just didn't know where to go because they got a little confused because I'm talking about slope and making sure the slopes are the same and make sure or that the slopes are opposite and reciprocal. And then I give you a problem like this where you can't even see the slope, and that opens up a whole thing about this line has a slope of 0 and this one has a slope of undetermined or undefined. And I don't really want to go into that right now for our geometry video, but I want to just go over one thing with you and see if you can figure it out. If you got a Y line, remember what we talked about in our previous video, Y lines mean cross the Y axis at 3. So I'm just going to draw a picture here real quick, but this says cross the Y axis, that's this guy, at the number 3. 1, 2, 3. So I'm just going to draw a little line across. And that's the graph of Y = 3 right there. But how about the other one? It says X = -6. Well, that means cross the X axis at -6. Well, guess what? When those two lines cross, even though you don't have a slope to compare and all that stuff, and you don't have a lot of the same data, but when you think about it in this view, from a graphing view, Y lines are horizontal, X lines are vertical. Therefore, these lines intersect, and they always make 90 degrees. They're perpendicular. So if you have a plane, just an X line and a Y line, they're going to be perpendicular because you have a horizontal meeting a vertical, and they are always perpendicular. I hope this helps you out, and have a great day. Bye.